Good morning and welcome to our webinar today in our Boston Tech-Update series. First of all, I just want to give you a short explanation about Boston, who we are, and so that you can that you know where we are. We are a solution factory for servers and storage systems and create customized solutions that are tailor-made exactly for the needs of the application. So you will get that what you need exactly, and we are very happy to support you there to find the right server or storage application for your data center environment. Today we want to take a closer look to the Enterprise Cloud SSDs from our technology partner Micron Technology, and they will present the latest trends and news about it. For this reason, it's a pleasure for me to introduce Esther Spanjer. She's Director Business Development. Sorry, Esther, can you click for the next slide? I have an issue here.
Yep, here you go.
Thank you very much. So Esther Spanjer is Director Business Development for EMEA from Micron, and she will give us some more insights into Micron's SSDs Cloud series on behalf of Micron, and will explain when it's recommended to take an entry drive, for which scenario they are working best, and also for the high performance ones, so that you can decide which is the best drive for your application. And of course, I would also introduce myself. My name is Andreas Schlemmer, and I'm responsible for the product marketing at Boston, Germany, and also for the entire DACH region. Before we start with Esther's presentation, I would like to point out that it's the Tech Update will be recorded and also uploaded onto our YouTube channel. And in addition to that, you will get the presentation and all the collaterals after the webinar. I guess I will send it out today, or maybe latest on beginning of next week. So if you have any questions, please use the chat function, and we will be happy to answer them after the presentation. I'm also very happy and very pleased today that Micron supports us with a special deal, like the last time that we had with our memories and DRAM webinar. So we are able to include a prize draw after the webinar, so you can win twice today. Once in the knowledge and how to optimize IT budgets, and on the other hand, if you answer our short survey, it's only 5 questions, so it's very easy to do. After the webinar, you can qualify for a crucial 2 terabytes portable SSD, and I guess it's an absolutely amazing prize, and we will do the draw after the webinar and will inform you as the winner and send the prize directly to you afterwards. Good, so now let's get started, and I will hand over to Esther, and she will start with the presentation. So Esther, it's your turn. Thank you for supporting us today.
All right, thank you, Andreas, and thank you all for joining us. You know, I decided not to put my typical business picture here. Instead, a little picture of you know, my personal life, since you know, we are all so far away all the time. I just thought, you know, a little bit more personalized was nice. So this is my new puppy that I recently received, and she really enjoyed my skin after we went for a run together. So thank you. Today we are going to talk about SSDs, specifically how to choose them. We also talk about some trends specifically in NVMe, since that is the upcoming interface of choice for the majority of new servers. And we also will have a topic on hard disk drive replacements and why QLC SSDs make sense for that. Of course, as Andreas mentioned, if you have questions, please put them in the chat box, and I will try to answer them as we go along. But I want to start off with you know, just a few slides on Micron, in case you are not fully aware of who we are and what we do. when we look at Micron, we really are a company that is, enabling the processing, the manipulation, and the storage of all the data that is created every day. And there is so many different sources of data that we are creating, that we are storing, that we are processing and analyzing. 2.5 quintillion bytes of data. To me, that is like an unimaginable number. But you can see here some of these applications that are all needing memory and storage to to do the processing, analytics, storage, transferring, etc. And that's really where Micron comes in. We provide products to do that storage in the form of DRAM, when the storage needs to be or when the sorry, not when the storage, but when you need to do processing and calculations, you typically store your data in DRAM temporarily while your CPU does whatever it needs to do, and also in flash flavor. So Micron is the manufacturer of both DRAM and flash on a chip level, as well as in a full end product level. In the case of today, we specifically will talk about the SSDs that are going into data centers. And so if you look a little bit about some of the numbers related to Micron, we did last year, our fiscal year runs from September to September. We did $21.5 billion. We are the 4th largest semiconductor company in the world. And we are located really across the world, 17 different countries, headquartered in the United States, but manufacturing primarily in Asia. We are, a fairly large company, 40,000, people worldwide, and so definitely, a company that is on the map when it comes to semiconductor and memory. In fact, if you compare us where we stand, in relation to our direct competitors, on the left side, you see we are the 4th largest semiconductor company in the world. And if you specifically look at memory, so when you look at both DRAM and NAND memory, the manufacturers in the world are listed here, and we are the 3rd largest, very close in size to SK Hynix. So a company to be reckoned with, and personally a company that I'm very proud to work for, not only because of its technology, but also because of a very strong focus on social justice, environmental issues and topics. And the company is really spending a lot of time and money to support a lot of those topics. The manufacturing, as I mentioned, is primarily in the Far East. China, Japan, Taiwan, Singapore, Malaysia is where we primarily make our SSDs and DRAM products. And then in the United States is where we have our headquarters, as well as the majority of our R&D sites. Europe has some R&D sites, and then the majority of that our sales offices in the various countries. All right, that is really the update that I wanted to give you on the company. I didn't want to spend too much time on it, but I thought just a little bit of a quick refresher of who we are. Today we are going to talk about NAND flash and SSDs, and I wanted to highlight, Micron has been traditionally a very strong DRAM vendor. We've always been, leading, technology in DRAM, but for many years we were in catch-up mode on the NAND side. That has actually changed as of last year. On November 9th, we announced to the world our 176-layer NAND flash. We were the first to announce that technology, and we were the first to ship that technology in our products. Today, they are shipping in our consumer and our client products, and very soon, later this year, they will start shipping also in our cloud products. So it is a very big milestone for Micron to finally say that we are leading the market in both DRAM and NAND technology. That is a first for us, and so I'm very proud of stating that, because it wasn't a trivial matter before. So the main topic of today, how to choose the right SSD, and there is lots of discussion and technical data that can go behind there, but the first main decision that customers should take is a decision between SATA and NVMe. And the answer to whether you use, you're going to implement a SATA drive or an NVMe drive is really very simple. Are you planning on upgrading your existing infrastructure? Most likely you will choose a SATA drive because most likely that infrastructure does not yet support NVMe. Are you going to buy new infrastructure? Then the answer absolutely is you're going to choose NVMe technology, because every new server that is being provided to the market will have support for NVMe slots and for NVMe capability. Now there is all these different applications that can work on your server. Both SATA and NVMe will be able to enhance those applications, but it's really the hardware where you're going to plug those drives in that really determines whether it is SATA or NVMe. I can tell you that SATA is definitely not dead. I hear many times comments like, oh, SATA is done, it's all NVMe. You'll be surprised how many legacy infrastructure there still is. It is a little bit similar like fiber channel. I think for 10 years people were saying fiber channel is dead, and it is still alive today, and that really is the case with SATA. We are the leading SATA SSD provider in the market today, and I can tell you that our SATA sales are still very strong because of that legacy infrastructure. Now, again, the new when we talk to customers about new projects and new infrastructure, we talk with them about NVMe, but there is many customers that want to get more life out of their existing infrastructure. They want to do a midlife upgrade kicker to extend the service capability of that server for a few more years, and that really is where SATA comes into play. But having said that, NVMe is the future. And today the NVMe market is kind of splitting into two different segments, the high performance segment and the mainstream segment. And to explain the difference between those, I kind of want to share with you a little bit of a history as to how we got to these two main segments. So I want to start off with the very first NVMe device that was brought to the market by a company called Fusion.io. They had the brilliant idea of putting flash onto the PCIe bus so that the applications really could take full advantage of the performance of flash. Because if you put flash in a hard disk drive form factor with a hard disk drive interface such as SAS or SATA, you really are not taking full advantage of what flash is capable of. So Fusion.io did this, and really what they allowed to happen was to create a device that has very high I/O performance and very low latency, because you are sitting directly on the PCIe bus. The challenge with this particular product was that there were no standard drivers. For each different operating system, Fusion.io had to provide the customer with a custom driver. It is clearly not a standard form factor. It wasn't hot pluggable, and the PCIe bus still was capable of drawing up to 25 watts of power. And so there were definitely some downsides to this product, but the main upside where people were implementing this class of product was because of the performance. If you were performance hungry, then this was the product to look at. Now, as the market kind of evolved, we came out with the Nvme Spec, and the Nvme Spec allowed us to put flash still on the PCIe bus, but with a little bit easier form factor. we called it U.2. Even though it is exactly the same dimensions as a 2.5-inch form factor, but somebody decided that U.2 sounds, I guess, more, I don't know, flashier. But we kept by doing this, by going to an NVMe interface and form factor, we were able to keep the high I/O performance and the low latency. But now we were able to take away some of those disadvantages because now we had a standard form factor that everybody knew. There were no more drivers needed or custom drivers because now every operating system had an NVMe driver already as part of the operating system. It was hot pluggable, and the only downside really was that it potentially could draw still up to 25 watts of power. But this class of product is still on the market today. Micron has a product in this category called our 9300 series, and if you want really high performance, then that is the product to focus on. Now at the same time, we have also a mainstream category, and that really comes kind of traditionally out of the evolvement of where customers wanted SATA to go. So SATA SSDs, were and are very popular because they have a standard form factor, a standard interface. The power consumption is not too high, but the challenge with SATA was that there was a maximum speed limitation of roughly 500 megabytes per second, and there was no SATA roadmap beyond that performance. So customers were looking for a more moderate performance, more moderate power consumption drive, but they really couldn't get beyond the SATA limitation. And so that's where mainstream NVMe came around. We basically took the Nvme Spec, but in this case we said, let's provide a maximum power consumption up to 12 watts. So that in essence is the same power consumption as 2 SATA drives. We still have the standard form factor and interface because we have the Nvme Spec and the U.2 form factor. But now, because we moved to NVMe, we actually have a roadmap to much higher performance. And so what these mainstream NVMe is capable of providing is on a megabytes per second per watt, it provides much better performance because it takes twice the power, but it can provide up to 7 times the performance. And so that is really where mainstream NVMe has come into play. And that is a very big part and a large growing part of the market, the follow-on to SATA, if you will. In the Micron portfolio, we have a product called the 7300 that fits that particular profile. But that I just really wanted to kind of share with you a little bit as to why we have these two classes of products and how they historically came about. So today in the market, you have high performance NVMe and you have mainstream NVMe. The big difference between them is how much potential power they can draw. And with flash, the more power you draw, the higher the performance you can get out of your flash. So looking at the portfolio that Micron today has, you see here on the right-hand side, our high performance class drive, our 9300 NVMe device. Then one step to the left, our mainstream NVMe device. Remember, that is, if you will, your follow-on to SATA. That is our 7300 series. Then we have a mainstream SATA, a very popular product. We still are selling a lot of bits in this class of product, our 5300 series. And then on the left-hand side, we have a QLC SATA device, our 5210 series, that really is focused on replacing hard disk drives. And I will talk a little bit more about why we think that QLC is the right technology to replace hard disk drives. So that is the current lineup of Micron. But let me, go a little bit further and explain to you, a little bit some of the features as well as some of the trends that are happening in the NVMe space. So one feature that I think is interesting for a lot of customers is something that we call flex capacity. This is a feature that works with all of Micron drives. And what it really allows you to do is to change the capacity and or the endurance of your drive based upon your needs. And why is this interesting? Well, for example, if you are a cloud hosting company and you want to limit the amount of SKUs that you have on your shelves, you can basically buy one base SKU, and then depending on what your customer requirements are when they buy certain services, you can configure their drive for that particular workload and endurance needs. And so that really gives you very, very big flexibility and allows you to use the same SKU for multiple purposes. And in data centers, the less SKUs you can purchase and have on the shelves, typically that is the desirable way to do it. Alternatively, if you have multiple workloads that you don't necessarily know upfront what is going to run when, you can use this as well. And so it really gives you great flexibility to adjust the capability of your drive to the workloads that you're planning on using on that drive. And you can change that also halfway throughout the life of the drive. So it's not like you've set it once and then you're done. You can take out the drive, or you don't even have to take it out. You can actually reconfigure the drive in the server if you want to have it used for a different purpose. So a great tool and technology that enables the highest flexibility for your implementation. So I want to move on and talk a little bit about some market trends in the NVMe space, since that is where the future of SSD is going to be. NVMe is clearly the interface of choice for all of the new infrastructure that is being bought. So how is the market splitting out in terms of form factors? You see here there is quite a lot of form factors that you may be aware of. U.2 is the main form factor today. That is being followed on by U.3. And so the U.2, remember, that is that 2.5-inch form factor. U.3 is the same form factor, but supports PCIe Gen 4, and I'll talk a little bit about that in the next slide. You see M.2 is slowly reducing in popularity, and it is being replaced slowly by these kind of new form factors called E1.L, E1.S, and E3. E1.S and E1.L, the S stands for short and the L stands for long. You may know these form factors, the E1.L as the Intel ruler. It is a caseless design and really is kind of the next evolution, if you will, of M.2. So let me show you how that looks. So on the left-hand side, this is currently what is shipping in the market. We have, your traditional SATA drives, then you've got your 2.5-inch SSDs, 2.5-inch if it's SATA or SAS. There's even 3.5-inch U.2 and U.3. We've got M.2 form factors, and then the PCIe card form factor, the HHHL, that stands for half height, half length. That is really a form factor that is very quickly dying. Now, we are currently in a transition period, and so when you look at the PCIe form factor, that will continue to have very, very little demand, and eventually will move on to the E3 form factor. M.2 will, in the coming few years, split demand between continuing with M.2 or potentially with E1.S, and eventually the expectation is that M.2 will no longer be supported and all the demand will go to E1.S. Again, S stands for short, and then 2.5 inch U.2, U.3 will move to will stay with the same form factor, or longer term will be split out between these different flavors, E1.S, E1.L, and E3 in the future. And then finally SATA will continue or move to U.2 and U.3 depending on what the needs are. So lots of different form factors, not an easy market to navigate. The expectation for the channel is that the two main form factors in the next few years will stay M.2 and 2.5 inch or U.2/U.3. We will not see as much E1.S. That is really a demand driven by very, very large hyperscale customers such as Facebook, Google, etc., that are trying to strip out as much cost out of these drives and plug these drives into 1U form factor servers to really get as much capacity and performance out of a 1U box. So let me talk to you a little bit about some of the details, U.2 versus U.3. The current NVMe drives are U.2, but as we are moving to PCIe Gen 4, you will need to transition to a U.3 slot. And the reason for that is that U.3 supports that PCIe Gen 4 and U.2 does not. Additionally, a U.3 slot can also take a SAS or a SATA device. And so that is really a great addition, so that when you have a server that supports U.3 slots, you do not have to choose anymore. You can take SAS, SATA, or NVMe SSD and stick that into that same slot. So it creates more flexibility, and it provides maximum opportunity to continue to transition even some of your older hardware, SSD hardware that you may want to transition into some of your newer servers that in the past you couldn't because your SAS and SATA devices were useless. Now you can potentially continue to use that also in your newer servers. So that is the big difference between U.2 and U.3. A few other differences between U.3. There's actually going to be two flavors of U.3, a 15mm height and a 7mm height. The difference between those really is that, remember, that high performance NVMe versus the mainstream NVMe, 25 watt versus 15 watt. So it really is a matter of how much power we can draw, and as a result, how much performance we are going to get out of that drive. E1.S is, as you saw earlier, is slowly going to take over the M.2 market, and the reason for that is that it has slightly better power consumption and thermals over M.2, and so it can be used both for boot as well as for a storage purpose or a caching device. So it has a dual purpose, whereas the M.2 typically only was meant as a boot kind of device. So this is currently the what we are expecting in the next few years in the NVMe space, the main form factors that are going to be dominant in the NVMe space. Hold on. Just a few words on E1.S compared to U.2. It just shows you here some, front view, side views to give you a little bit of an idea why, what it looks like compared to your traditional U.2 or U.3 form factor. You can see it's slightly longer. It is substantially smaller, and it has a completely different connector. So why did the industry come out with a product like this? Because we are trying to optimize this kind of form factor for for 1U servers. So the intent really is to stick as many of these modules into a 1U server so that you can get as much capacity and performance into that 1U box as you possibly can get. This, as I said before, is really a trend that is being driven by the large hyperscale customers, Facebook, Google, Amazon, who have hundreds and thousands of servers in their data centers and want to optimize every centimeter of that data center. I don't see this form factor being quickly adopted in smaller data centers and channel customers, but eventually, the market will go there as a result of, what the big hyperscalers are doing and where the majority of the demand will be. So that is just, some words on what we can expect in terms of trends for NVMe form factors. The last thing that I want to share with you is QLC SSDs and why they are a good choice for replacing hard disk drives in certain applications. So, I think it is clear to all of us that, there's tons and tons of data being created every year. The analysts are saying that we are doubling the amount of data that we create every 2 years, and IDC is stating, in 3 years from now, 4 years from now, we are going to have, created 163 zettabytes. Like that's just, I don't even know how many zeros that is, but it is a lot of zeros, and clearly, that is all really being created by all of these different, applications that are, needing to have store data, manipulate data, and analyze data. And so what that really means is that, when you're putting hard disk drives, with these applications, in many cases, they are the bottleneck because of the performance, and it slows down in many times the analytics or the access capability of that data. And so that really is where QLC technology comes into play. We are seeing a trend where QLC SSDs were originally replacing 15K hard disk drives, and then starting to look at 10K hard disk drives, what is really where we are today, and then slowly starting to also take some of the market segment of 7.2K, so 7200 RPM hard disk drives and beyond. And really the reason for that is that the application requirements are becoming more and more performance sensitive, and hard disk drives are just not capable of providing that performance. And that really is where QLC comes into play. They are designed to be the hard disk drive replacement, to have better performance than hard disk drive, to have better endurance and reliability than hard disk drives, and to really focus on those workloads that are more performance sensitive, where hard disk drives aren't able to keep up. QLC SSDs are not designed to become a lower cost version of TLC. That is really not what the intent is of a cloud class QLC product. We do see QLC, of course, in the consumer space, and that's where in many cases endurance is not the problem. It's all about the cost. In the case of cloud, we are looking at both endurance and the cost, and so that is where QLC SSDs are providing a very, very good value proposition. So to give you some ideas of where we are looking for replacing hard disk drives, really when it is the performance, when it is with the reliability, and when it is with regards to access time. And so time is money, and so when you are looking at specific applications, and let me show to you some of the applications where we are seeing the hard disk drives being the bottleneck. For example, take artificial intelligence and machine learning, the ingest of data, when you have hard disk drives in there, and then the analyzing, that typically takes longer just because the hard disk drive doesn't provide the performance that an SSD does, and so you can potentially reduce your learning cycles to hours or even minutes instead of 12 hours or longer. And so in applications where time is money, clearly that can be a big difference. Also, when it comes to power, hard disk drives are much more power hungry than SSDs. In today's data center, power is a key factor, especially when we're looking at all the regulations of how much power data centers are going to get. And so SSDs really can provide additional benefits when compared to hard disk drives. And again, QLC is going to be as close as possible to hard disk drives when it comes to the cost structure that you're going to get. So if you look at where we have had success, I can tell you that the 5210 has been qualified by pretty much every OEM in the market: HP, Dell, Lenovo, you name it, Supermicro. And we have had tremendous success with those OEMs replacing their 10K RPM offering with the QLC SSDs. So what kind of applications? We actually have done a lot of research on what the benefits are of SSDs or QLC SSDs versus hard disk drives. The applications that you see here, we have white papers, research, we have test configurations. We have a lot of data behind all of these applications that if you click the link, you will get to that information. We have kind of like a one-pager that explains you in very short kind of the results, and then we have an entire white paper with the test script and the test setup, etc., that really shows you the details of how we got to those results. So if you have a specific application that you want to know a little bit more, you will get a copy of this presentation, and I highly recommend that you use those links. Of course, I am also happy to answer any questions you have once we are finished with this webinar. Oops, why don't I want to do it? Okay, here we go. And so I want to finish off with kind of an overview of the products that Micron has to offer in both SATA and NVMe, and what is the kind of the best fit for these different applications. The more blue you see, the better the fit is, and so hopefully that gives you kind of a quick and easy view on which product should you choose for what application when you are looking at Micron as your vendor. And with that, I want to open it up for questions from the audience.
Good. So thank you very much, Esther. for the presentation, for all the informations. I think it's very great to see where the standard is going to with all these interfaces, especially for and the development of the SSDs for the next years. So thank you very much for this update. I will have a look at the moment. There are coming no questions in. Just a second. So I will use the time for that. So please fill out the survey after the webinar, and you can win 2 terabyte SSD external drive from Crucial respective Micron. So thank you very much for that again. So I will have a look. There is a question. So Esther, how do you see the situation about GIA cryptocurrency so far?
That's a great question. I get it lately about every call I am on. It is a very volatile topic. One day Elon Musk tweets that it's not good, and then the market crashes, and the next day it's up. So having said that, the current SSD market on the cloud side is highly constrained. So it is very difficult for people to actually buy SSDs for this kind of crypto mining purpose. What we do see is that as a result of that, people are starting to buy more consumer drives. The challenge that you have there is that these applications for that crypto mining are very write intensive, and so these consumer drives will wear out very quickly. I obviously recommend not to do that. I can tell you that from a warranty perspective, Micron will not, our warranty is 3 years for our consumer drives, 5 years for our cloud drives, or if the endurance of the drive runs out before that. So it's whichever comes first. And so when we get drives back for an RMA, we are actually able to look at the endurance of the drive, what is left. And so, we will not replace any drive if it is past the endurance. Also, our partners, we have tools where you can actually check the endurance, how much the drive is being used, so that if you have a concern that, the drives that you sold and are coming back are being used for that crypto mining, you can actually check with some of the tools we have if that endurance is truly, still there, or if it's worn out, and so you will not have to service that. So it is a tricky topic. We see, a lot of interest for it, but I think it is a very volatile situation at the moment. How it's going to develop, time will tell. But in the interim, if there is concerns about getting products back that customers have bought, please know that we are fully aware of that, and we have the tools to check that to make sure that this will not happen, without validity of how these drives are being used.
Okay, good, fine. So there are coming much more questions in. So when can we expect the PCIe 4 SSDs?
Gen 4.
Gen 4, yes.
So we will have, stay tuned. We will have some announcements on that coming very soon. That's all I can say, unfortunately. But call it soon.
Okay, good. So as soon as we will get an update from you about the availability, then we also will inform our partner landscape for sure.
I would love to do a webinar when we get there. So yeah.
Okay, good. I will come back to you regarding that. Okay, next question. So I'm wondering why the manufacturer decide what the customer needs. Since years we would have been needed the ruler format. Now there's a service, but still we do not get the E1.SL for SSD solutions.
Well, clearly the manufacturers are doing a market research and understanding where the biggest demand is. And so if there was a large demand for the E1.L, which is the ruler, then they would have gone there. I can tell you that from our internal research and discussion with customers and fully understanding what the demand of the biggest part of the market is that the E1.S actually is the more popular form factor, and that is where we will initial focus our development on. We will eventually come out with also E1.L, but our first entry into the market will be with an E1.S.
Okay, so I hope we could answer this question. The next one. So how about availability? Currently, nothing can be scheduled.
Yes, it is a very challenging market at the time, both on the DRAM side and the SSD side. I think it's a unique situation that has never happened before. It's a combination of a few things that happened that created this situation. There were a few weather related events or natural related events. There was an earthquake in Japan. There was a major winter storm in Texas that caused a power outage at one of the Samsung fabs that where they make their SSD controllers. They were out of power for about a month. There was an earthquake in Japan that impacted the manufacturing capability of Toshiba and Western Digital. There is also the world is coming out of a pandemic, and so the demand is also rising as a result of that. And on top of that, the world is seeing a major shortage of semiconductor material, which is what we need to make controllers for SSDs. So it really is a combination of many things that brought us to where we are. Now, that doesn't help you in giving you an answer on when you're going to get your products. I just want to give you a little bit of a view as to, where it is coming from. The expectation for the SSD market is that we will continue to be in a highly constrained market throughout the rest of the year. And in fact, Q3 will probably be the most constrained market out of the entire year. So the next few months, it will be very, very difficult to get parts with short notice. Lead times will be long. And prices will go up, and this is not related to Micron or to it's really across the board. All the vendors are struggling to keep up with demand. I can tell you that in Micron, if I look at the European demand, I could probably sell twice as much as I get in terms of bits. And so it is for us, what we are doing is we are very much focusing on giving the right customers the right priority. We will not just ship anything that is on backlog. We will scrutinize every order that is being shipped to make sure that we're not just shipping for somebody to put the orders, the parts on the shelf, and then be speculative with the price and then sell them in a few more months to make a lot of money. We truly will look at which orders will have real customers behind them and will really need those parts. That is our strategy. It is still we're not going to be able to make everybody happy. Personally, I am going to be responsible for the next 3 months to approve every order that is being shipped, so that we can surely prioritize those customers that we want to see prioritized. So if there are specific needs, please talk to Boston, who will then talk to us. But it is a challenging situation, and lead times are long. I will not deny that, and prices will continue to go up. So unfortunately, that is the situation. So get your demand in as early as possible is right now the best strategy that I would recommend that you do.
Okay, yeah, very challenging, a very challenging
Yes.
time for us. So yeah, as Esther said already, please work very close together with our sales guys to plan your projects so that we can also order as fast as possible, plan as good as possible, and you can be sure we will do everything to get products in as fast as possible. But yeah, as said already, it will be very challenging for the next months, and we will see how we can.
I mean, I am talking to customers, to many customers already about September supply. So that is the situation right now. And as I said, it will not improve much in the near future, unfortunately. I wish it was different. I rather chase customers than customers chase me, but that is the situation as we are in.
Okay, is there the possibility to increase the production capacity? It's a next question.
What we're doing already is we're trying to steer as many bits that we have away from consumer and put them into our cloud products, so that we can potentially increase our cloud SSD manufacturing capability. But with all of that, we are still in a highly constrained situation. So no, it is with memory semiconductor manufacturing, it is very difficult to quickly increase the production, because building a new fab typically takes 1 to 2 years, and typically is an investment between $6 and $10 billion. So it is not something that happens overnight, and clearly is very, very carefully analyzed because of the major capital investment that is associated with that. So no, it is not unfortunately not a short fix that we can do as an industry to meet the demand in short notice.
Okay, good. So then I have another question. Go back to the technology wise. What about capacities beyond 15 terabytes? Are there any planning so far?
Yes, there is 30 terabyte is on the horizon from multiple manufacturers, and I would say you will start seeing products with that capacity point sometime in the 2022 timeframe.
Okay, good. And these are hopefully available then. Just kidding.
Listen, I would love to sell a lot of 30 terabyte drives. Trust me.
For sure. Okay, and then we need to go back to the shortage questions. But isn't the shortage due to the launch of new mobiles? Even most people have already a mobile.
So the demand for NAND comes from a variety of markets. It comes from the 5G mobile phones that are selling more phones because 5G comes up, and so a portion of Micron's revenue is coming from the mobile market. A portion of Micron's revenue is coming from consumer drives, and a portion of Micron's revenue is coming from the data center. So the challenge that we see is that the demand from all these three market segments right now is very, very high. As you can imagine, the mobile section wasn't wasn't really big because when people were at home, they weren't buying new phones, but we had a very, very big uptick in demand on the consumer side because many customers were upgrading their laptops, because everybody started to work from home. We also saw a huge uptick on the data center side because everybody was working from home, and so all these online things needed to be working faster. So we saw a big increase in demand on the consumer side and the data center side over the past, if you will, 6 to 8 months. And now with the 5G technology also coming up, we're starting to see also that demand. So the demand is not coming from one side, it really is coming from a variety of markets. On top of that, also the automotive market. Last year, as a result of the pandemic, the automotive market, dropped dramatically. There was like about 30 to 40% less cars being manufactured about a year ago. And then within, kind of towards the end of last year, that demand started to pick up again, as a result of the world slowly coming out of the pandemic. And so now the car manufacturers actually cannot produce as many cars because, they don't get the chips that they need to actually, for the electronics that they need inside the car. And so what we are seeing as a company is that the demand, across these different market segments, all for different reasons, are picking up, and so we are, challenged on pretty much every front when it comes to meeting the demand at the moment. Now, having said that, we do have a how do you say that, a preference to sell as many bits as we can into the cloud space, because that is where we typically get the highest margin and the best pricing structure. So we have a vested interest to take as many bits as we can and make cloud SSDs out of that. But again, not every bit that we produce is capable of being put into a cloud SSD.
Okay, good. So thank you very much, Esther, again, and I guess there are coming no other questions in so far, so we can walk through. Can you do the next click? Oh, we are finally on the end. So, so thank you very much, Esther, and again, please do not forget to fill out the survey for for our prize draw afterwards, and we will inform the winner after the webinar, like we did it on the last webinar as well. So it's very easy to fill out, so do not forget it. And yeah, then I want to say thank you, Esther, again for the very open and clear words about the current situation about the deliveries. I know it's very tough. It's very tough for all of us. And if you prefer to ship the most of the drives over Boston, then it's and you will have one happy customer, and we have a lot of happy customers finally. And yeah, thank you very much again. I think we can close the webinar right now. I wish you a nice, great, sunny weekend. And for those who will go on vacations, a nice holiday and a safe time, stay healthy. And thank you, Esther, again, and thank you for participation and for all the questions which has been asked so far, and for all attendees here. Thank you very much. And
thank you so much. Very much.
Thank you.
Thanks, Andres.
Bye-bye.
Bye-bye.
Thank you, Esther.